So these are the previous index laws you should have known already. The additive index law, or the multiplicative one, depending which side you're looking at. The division one, the expansion of the brackets, and the unitary one. About year 9 you start to realize that a to the power of 0 is 1, and then you look at negative powers, which is a to the power of x is flipped over to get a to the power of negative x. And vice versa, you could also have 1 on a to the power of negative x equaling a to the x. Because what you're doing is you're flipping them over, if you like. If you flip that over, you'd get a negative, and you flip that over, you get a negative of a negative, which is a positive there. And you've got the fractional indices, which I'll explain to you in a second. You also have, for example, the nth root as 1 on n powers. So if I have the square root here, that's got a hiding 2, which you don't usually write in. That actually gets written as 41 to the power of a half. Here's another one. If you evaluate 25 to the power of half, you've actually got to rewrite it as square root of 25, and hopefully you know that 5 times 5 equals 25, which is what the square root means. Rational indices are basically a fancy word for fractional indices. And so in this case you can either put x to the power of m on the inside and then take the nth root, or you can take the nth root first and then raise it to the power of m. So I'll do an example. So if you do it the first way, if you take the power of m first, that means you cube the 25 first, and then you take the square root, and that's going to get a really huge number. I'm not really a fan of this way, but here's how I do it. 25 times 25 is 625, and if I multiply that again by 25, I will get 15,625. Yes, I cheated, I looked at my calculator. So then if you take the square root of this, you've got to basically either know your square roots or have a calculator handy. After some calculations, it becomes 125. Not such a fan of the method on the left. If you do it the right hand side way, you take the power of half first, which means you square root the 25 first, and then you cube it. So you get 25, square root of that, and then cube it. And you can see that you get smaller numbers to work with. So the square root of 25 is 5, and then you cube that, and it's much easier to cube 5 than it is to do all this stuff over here. So 5 squared is 25, and so 5 cubed is 25 times 5, which is 125. Okay, so the same index laws still apply to rational indices. The first law, which would be to multiply, would be to add the indices. So I'd have x to the power of half plus 2/3 and y to the power of 3 plus a half. Okay, so this is where you need to practice your fraction. A half plus 2/3. You find a common denominator of 6. So you have 3 on 6 and 4 on 6, so the answer is 7 on 6. And for the y, it's a little bit easier. 3 plus a half is 6 on 2 plus a half, which is 7 on 2. Okay, so here's an application. Real aluminium atoms have a radius of 148 picometers, where picometers are very tiny fractions of a meter. So a picometer would be 1 with about 11 zeros before it. 3, 4, 5, 6, 7, 8, 9, 10, 11. So that negative 12 means that I had to hop 12 spots from the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So instead of working with really tiny numbers, we use scientific notation. So the aluminium atom has 148 times 10 to the minus 12 picometers of radius. So if we put them end to end, you can see that we have to double the radius for each atom. And there's 2,000 of them. So you've got double the radius, and you've got to multiply that by 2000 to see how long that would make. So to make it easier again, I can use that in scientific notation. So I get 2 times 148 times 10 to the minus 12 times 2 times 10 to the 3. So then you get 592 times, then you can group these using the index laws. 10 to the minus 3 times 10 to the 10 to the positive 3 times 10 to the minus 12 is 10 to the minus 9. And the lucky last bit is to convert it back to scientific notation, which would mean we got 5.92 times 10 to the 2 times 10 to the minus 9. So you ended up with 5.92 times 10 to the minus 7 meters. Another one's Pythagoras. You've got a base length of 100 centimeters. You've got a height of 75 centimeters, and you want to find the diagonal. So it's a right angle triangle, so Pythagoras says that c squared is a squared plus b squared, or if you do it with index notation, c is a squared plus b squared to the power of half, which is 100 squared plus 75 squared, and you take the square root of that. Now that works out to be 125 after a little bit of work. You need to use your calculator to do that. Okay, so here's some general principles. You can put that in your notes as well as the first 8 index laws. You have to expand the brackets first. If you don't like negative indices, change them to positive and reciprocate or flip them over. Third, you evaluate any numbers. Fourth, you use any index laws. You're going to try doing this before we get to class. Here's the first example. Here's the second one. Here's the third one. Okay, so you got the right idea. So if you see the rest of the slides, those are what I'm going to go through.